In this video, I'm going to walk you through how I built this sandbox play area, featuring a marble machine. Stay tuned. As a kid, I always loved the outdoors, but I never had a backyard or a place outside of my own to play. So a few years ago, when I became a father, I knew that I wanted to give my son a place of his own to play and explore. So we were lucky enough to have a small corner out back that seemed to be missing something. And I knew I wanted to make a sandbox, but I also wanted it to be something special, a place for his imagination to run wild as he got older. So I came up with an idea for this play area. The materials can be found in most home centers and can be built with a few basic tools. You can use a 4.5-inch circular saw with the speed square for most of the cuts. I will have a video showing how to make the cuts with this saw for this project. You'll also need a tape measure for obvious reasons, a power drill and a variety of drill bits. A pocket hole jig is not necessary, but it does help. Building the maze portion, you will need a level, especially if the ground is uneven. You'll also need a jigsaw with a scrolling blade, an acrylic cutting blade, and a metal cutting blade or hacksaw for the aluminum rods. A step bit is usually known for drilling metal, but I found that it works really well for acrylic sheets. Hammer and nails and exterior screws are also necessary. A heavy-duty staple gun and staples are optional. I built this play area before I decided to put videos up online, but after I saw how much my son loved it, I decided to make a video about it and created this 3D model so I can show you how it was done. Since the ground I was building on was a little uneven, I had to first build a wood deck of sorts. So I used cedar 2x2s to build the base, and then from there I used 5/4 cedar decking boards, and I screwed them in place about a 1/2 inch apart from each other. You can use a 1/2 inch shim to ensure equal spacing. Then I cut the pieces for the sandbox. Before attaching the top boards, I lined the bottom of the box with some weed barrier fabric, since I didn't want the sand seeping through the gaps at the bottom. I used a staple gun to keep it in place. I then screwed the top with 4-inch screws. As you can see, I didn't cut the fabric all too well, but it really didn't bother me. With the standing sandbox, I wanted to make sure it had storage and was at a comfortable height. I used cedar 2x2s for the legs and attached the decking boards to make the frame. For the bottom, I measured out the inside and cut parts to fit. I cut 1/2 inch notches into the corners so the sand wouldn't escape through the gaps. I resawed the deck boards in half for the walls, but you could also use 1/4 inch or 1/2 inch plywood instead. When making the lid, it was important that the brace was wide enough to catch the screws for the hinges. The brace had to be shorter than the width of the lid, so they would close properly. The storage lid also needed to be shorter, so the door wouldn't get stuck. I drilled a hole and added a rope through the door and knotted it at both ends. This served as the handle for the door. After I made the lids, I used strap hinges and attached them to the sandboxes. To make sure that the lids stayed up, I attached a piece of rope to a wooden portion of the garage, and after every play session I had to make sure to close the lid so that no critters get into the sand. I also would cover it up with a tarp so that water doesn't seep in if it rains. The next step was to build the play area and marble machine. I cut grooves in the frame to fit the plexiglass. Just make sure that you cut them on the correct side of each board. The top can be attached with pocket holes, but I used these little galvanized angles that I had left over from a previous project. You'll want to leave it open until the end. The bottom of the boards keep the whole thing together in the meantime, and provide a place to attach the other components. I used the same steel angles to attach them to the deck floor. I also added a brace on the side for extra support. It's been through some intense winds and it hasn't budged yet. The center board holds up the wheel. I made a bracket/interface of sorts so the wheel would stick out and not get in the way of other parts.
So fast. So fast.
The brackets hold up the marble machine frame, which was grooved just like the sides. This ensured that the water didn't get into the maze. I used pocket holes for the top so it would be easy to remove for maintenance, or if I wanted to add more marbles. The tic-tac-toe panel was made using 2x2s. I drilled 1/4-inch holes equally spaced to hold the aluminum rods, and the blocks were made by gluing 2x4s together, which I then cut into cubes. I drilled holes through the middle and slid them into the bars. I placed washers to act as spacers in between each of the cubes. The abacus panel was made in the same way, but the holes for the aluminum rods were closer to the edge so they wouldn't catch on the back panel. The blocks were made from cutting 2x2s and drilling holes through the middle. I made sure the holes were slightly oversized so that the blocks wouldn't bind. Now for the actual mechanism, I drilled a hole at the bottom of a 2x2, which I sandwiched between 2 guides and a faceplate. I then ran rope through the hole and used eye hooks to keep it contained. I made the knob by drilling a hole through the center of a 2x2 and used washers and knotted the rope to hold everything in place. The marbles get ejected into the maze as it hits this piece, which is angled so that when the notched part that carries the marble is raised, it shoots the marble out. Here's a slow motion video showing the action. In order to make the marble maze parts, I planned out how I wanted the marbles to travel. I pre-drilled the plexiglass sheet and screwed the wood in place on both sides, and then I slid the entire contraption into the grooves. I also added a large metal ball bearing along with the marbles. This way, if any of the marbles got stuck, I can use a magnet to move the metal ball around.
He doesn't see it. He's a little too short. Down. Up. And out. Up, 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 up. Whoa! Yay! Whoa! Bing ball.
Plans for this build and more information can be found on my website. There's a link in the description below. Thanks for watching.